Hi, welcome. My name is Kip Harry, live at Discovery on Target 2012. I'm here with Minkui Liu, who's assistant member and professor of molecular pharmacology and chemistry program at Memorial Sloan Kettering Cancer Center. Minkui, how are you doing today?
Hey, how are you doing today?
Good.
Very good.
You're about to speak in about 30 minutes, but so far you've heard several talks. Now, which stood out to you the most?
I think this morning's two talk, Ben's talk and Ben's talk from UPenn and Ryan's talk from Epizyme really impressed me a lot because they really bring very new concept to understand the function of this important epigenetic enzymes from different perspective, from biochemical perspective, also from the technology perspective. That's really make us understand the function of those enzymes in a deeper stage.
What are you looking forward to this afternoon in terms of presentations?
Again, this is pretty diverse field. I like to see different people from different field, different division, how they see this question, how they see the future of this field, and how they see emerging question of this field. I think that's a great meeting. Really bring all type of people together to address this type of question.
Let's talk a little bit about your presentation coming up and a little bit about your work. So you're talking about profile substrates and inhibitors for methyltransferases. Can you tell me a little bit about what your work involves and some of the problems you encounter?
Sure. There are two projects in our lab. One is about identify the substrate and also the function linked to the substrate of individual methyltransferase. We think there a trend we realized initially those enzymes has been reported as histone methyltransferase, but we see more and more example those enzymes also target non-histone target. So really define the whole scope of the target is very essential to appreciate the function of the individual enzymes. So we also realized that without the non-histone target, a lot of time is just not sufficient enough to count the function and the phenotype we observed for individual methyltransferase. So we developed a lot of efforts to develop new technology approach to define the protein-wise the substrate of protein methyltransferase, and we have a couple of new probe and technology we think is very powerful, going to benefit the whole field. Yeah.
Some of the problems
we have another project. We also, based on our understanding of the biochemistry of methyltransferase, developed the novel scaffold that's as a potential methyltransferase inhibitor. So we do define a couple of xenofungin-based scaffold. They are very potent and selective, only target a subfamily of methyltransferase. We think that can be a new concept bring to the field to design better inhibitors.
Some of the problems we've heard reiterated over these talks. What are some of you that you're encountering in your own work?
I think the challenge, most of the challenge we have for our lab, also the people in this field, is really linked to the function of the individual methyltransferase to the phenotype we observed in variety of the contact, especially in the cancer contact. A lot of times the biology or biochemistry we know of those enzymes is not enough to explain all the phenotype we observe. Yeah, there are a lot of nice work such as these two. We understand much better how this mutation plays a role in different type of cancers. But for majority of methyltransferase, even we see the dysregulation of this enzyme. However, how this dysregulation linked to the function is still very weak. So I think that's a big challenge for the field because without a well-defined function, it will be hard to even validate those enzymes as the druggable target.
Absolutely. I'm looking forward to your talk in a few minutes. I'll let you go get set up, and thank you for speaking with us, and stay tuned for more.